The 360 on Energy and Carbon, hosted by 360 Energy. On today's episode, we have Dr. Hannah Mao and Mr. Terence D. Matulik from the University of Windsor. Dr. Hannah Mao is a professor in the Department of Civil and Environmental Engineering at the University of Windsor. He is also the Associate Director of the Cross-Border Institute, CBI, and the founder of its Traffic Lab. Dr. Mao is an expert in land use and travel demand modeling, cross-border and freight transportation, sustainable cities, geospatial planning support systems, and advanced GIS applications. To date, he has published numerous peer-reviewed articles and government reports, and his research has been supported by numerous funding agencies across Canada. Mr. Terence D. Matulik is a transportation and GIS analyst at the Cross-Border Institute, where he has been working since 2016. Terence recently received his MASc degree in civil engineering from the University of Windsor with specialization in transportation modeling. He has been involved in several transportation research projects since joining CBI. He is currently a PhD candidate in civil engineering at the University of Windsor. His research expertise are in land use and transportation modeling, travel demand modeling, GIS spatial analysis, stated preference SP survey design, and freight data analysis. Now let's get into the episode with Dr. Hannah Mao and Mr. Terence D. Matulik. Welcome back, Dave.
Well, thank you, Lysandra. It's nice to be back, and I'm again excited about the topic and the guests we have today, so it should be a really good one for our listeners.
I am as well. We welcome today's guests, Dr. Hannah Mao and Mr. Terence D. Matulik. Welcome.
So, Hannah and Terence, again, thank you so much for joining us, and I'm really looking forward to ask these questions and for you to share with our listeners some of the work that you're doing, because it is groundbreaking. I think people will find that as we get into this. So here's my first question for you both. Could you give a bit of a background on the project that you are working on with 360 Energy and other stakeholders as it relates to the electrification of heavy transport?
Well, the project is led by Dr. Luke Caribou, as well as Dr. Hannah Mao of Civil and Environmental Engineering at the University of Windsor. So in partnership with 360 Energy, IESO, as well as Nature Fresh Farms. And it is enabled through a grant from ITEX Accelerate. In a nutshell, this project is concerned majorly in the electrification of heavy-duty trucks, or you could refer them to as the big rigs as well. We're working on primarily on the movements of heavy trucks to identify where they typically stop to refuel. And then we assume that if the patterns of these trucks are the same, but the fueling will be electric, this will then allow us to evaluate the potential grids of charging these trucks.
So if I can, Terence, the objective is to see the impact of electrification of heavy transport and what it will do to the grid, and is the grid prepared for this possible onslaught, and how does the grid prepare for that?
Correct. Yeah, exactly. Because based on early experience, we see a small adoption with regards to passenger electric trucks. And it was shown that while the region-wide capacity is sufficient to meet these additional electricity demand, the bigger picture is not the same when we look at the local electric supply and grid infrastructure. So pretty much many areas will not have the capacity to service this new electric vehicle customers on top of these heavy duty electric trucks, right? So this concern, as I said, will kind of make it much bigger for heavy duty electric trucks. And will likely feature because they have much bigger batteries, about 16 times the capacity of a typical one. So this would make it much heavier compared to just typical passenger electric vehicles.
Yeah, what I find really interesting about this is I know this project is more so based on the agricultural transport, but I think that this will be able to be transferred to all other industries. And on that note, what is the purpose of undertaking this work, and what is the geographic scope of it?
So I can respond to that. As Terence was saying, basically the idea is to look at the electrification of heavy-duty trucks. We are considering basically heavy-duty trucks because it's a new type of alternative fuels that has not been examined in the past. And in general, when we talk about these big rigs, the size of the batteries is much larger. So there's basically a general misconception in terms of whether these trucks are going to be viable options, the diesel, the trucks. But in general, there are some concerns about that in the sense that basically the viability of whether these are going to become uh, a reality or not has to do with the better technology because there are still concerns about the range. So many think that the adoption of the electric trucks will not be as common anytime soon to put significant pressure on the electric. However, it's critical to plan ahead since the infrastructure cannot be built, and especially if all of a sudden electric trucks becomes a reality. If technology changes, and what we see basically is advancement and better technology happening all the time. So the work we are conducting basically will help us gain a better understanding of where and when these heavy trucks will be charging to prepare for potential system disruptions. As if you don't plan properly and you have heavy duty trucks all of a sudden that require basically that energy, that will put a lot of strain on the electric grid. The the geographic scope basically is we're looking at the province of Ontario. Province of Ontario is basically one of the most economically robust regions in North America. There's a lot of truck movements. We have Highway 401, which is the main arterial for the Quebec Transit Corridor. A lot of trucks, one of the busiest in the world and North America, with multiple international border crossings, for example, the Russell Bridge. And we think that the electrical grid system of certain places will be significantly affected if you have electrical trucks using the major highways that exist in the province. That's what we see is that there is a lot of clusters of trucks stopping at certain locations in proximity to these major arterials. And if you have electric trucks, all of a sudden, then basically they need charging. So assume that you have the ability to charge, you need to plan for that.
So this is a follow-up on what Terrence you had suggested, but just for our listeners, because I think a lot of times people can't put this in perspective on the size of batteries in a truck. You had said there it's about 15 times the size of a car. Some people won't even know a car size battery, but can you share with our listeners what you're proposing or thinking the battery size would be for these trucks so people can understand?
For sure. Yeah. I guess like a good way to kind of envision is just to give like a specific example. So like since almost everybody know Tesla is, so we could use the Tesla Semi as a good example. So based on what they're advertising, so like their battery capacity, like if we consider the long range one, it would be about 875 kilowatt hour up to 1 megawatt kilowatt hour. So we're not quite sure how big or how heavy that is, but what they're saying is it could be about like 5,000 kilograms for that battery size. So it's quite big and quite heavy as well.
Okay, and for our listeners, because the context of what you're saying of 850 to a 1 megawatt battery, there are some manufacturing facilities that their total electrical load just to produce product might be that size load. So effectively, if you're adding this into an organization and they're charging possibly at their site, it could be doubling the size of the electrical load. And most customers aren't, they think that electrical load, they can just plug in and away they go. And sometimes there's limitations. And so I just wanted to make sure our listeners understood how important this is and why it's something they should be aware of going forward. So thank you for that. So my next question is, who do you see are the key participants that need to be involved in implementing the electrification of heavy transport?
Yeah, there's quite a few that we could think about, but I guess like in no particular order. Like the government, this is one of the key players in this, mainly because, like they're the one who will regulate the type of trucks that will be seen in our highways over the next 20 to 25 years. However, like the type of regulations will be needs to be accompanied by proper incentives in order to encourage these early adopters, right? So for instance, the government could ease the initial cost of maybe owning or even leasing these heavy electric trucks through appropriate monetary support. Given that Canadian government currently offers only the tax write-off or for businesses who purchase these electric trucks, switching from diesel to electric trucks might not be cost effective for those who are leasing their fleets. So maybe, they could give a specific percent discount and how much monthly payment that they could have, or even buying these electric trucks. Also, in addition to the government, we also think that local utility companies is another key players because they support the development charging infrastructures that we need for the heavy electric trucks, right? Because charging infrastructure is a major deterrent for adopting these type of technology because currently there is no public accessible chargers in Ontario. So this prevents potential adopters from making long haul trips, right? So lack of public chargers also make it mandatory for the users to have their own. And that could cost hundreds of thousands of dollars depending on the type of the charger that they would need. So that introduced another cost element, not just the range anxiety, but also the cost element where it makes them a bit hesitant to adopt electric vehicles. So therefore, the government could also provide support in implementing home-based chargers, making sure that these businesses, specifically small businesses, current grid infrastructure can handle the demand as well as the cost needed to charge these big rigs. So in this regard, utility companies could also give a special electricity rate, just kind of throwing it out there. Maybe if they know that these businesses own maybe one or two charging point, you could give them special rates. And as well as, making sure that there's enough capacity to satisfy their demand. Also, last but not the least, is like the automotive industry, right? Because they could also provide like design and delivering these electric trucks that are comparable to their range to what diesel trucks are currently offering. So obviously, research in battery technology is also ongoing, but unless electric big rigs are set as a priority, it will likely take longer than expected to achieve the goals of getting the range to where it needs to be. So right now, most of these manufacturer companies are focused mainly on passenger vehicles, but definitely, the commercial side needs more attention in this regard. In this regard, Tesla is a leader as well because ever since they introduced Tesla Semi, or other companies such as Volvo, even Freightliner follow suit. So it goes without saying that eventually, automotive industry would need a government incentive to make this happen, producing these electric trucks to make it competitive as well, right? The cost of purchasing these electric trucks is also much higher than the diesel truck. Then fleets will not go for it since the industry has been known by running on a very thin profit margin. And right now, heavy electric truck will likely cost twice as much as their diesel counterparts. So it definitely needs some help in that.
Now, just for our listeners, I know we jumped right into this electrification, but the reason why this is being considered and the government's actually helping promote this initiative is to reduce the carbon emissions, because heavy transport, how they operate, and then the diesel they use does emit quite a bit of carbon emissions. So this is one way of actually reducing the Canadian emissions. So I want to put that out in front of people as well.
So you both have kind of alluded to this, and I know, Hannah, you've directly said this, but Ontario transportation is very heavy, and you mentioned the 401. And why I think Ontario is a great avenue to start this is because we do have en routes. So for people who are not from Ontario, along our 401, we have these pit stops where you can get gas, you can, get food, things like that. So having en routes would be a perfect opportunity for electric vehicles because it would be a stationary spot along their routes to fuel up, similar to gas. Because I know that's a big issue with a lot of EV vehicles, just regular car vehicles, is that lots of people are having the issue with, there's not enough charging stations, things like that. So both of you being transportation specialists, could you discuss the merit and value of electrification of heavy transport? And what do you find is most exciting to you?
So I think any other new electric or any other new technology, heavy electric trucks, it has its own benefits and merit. I think one of the main selling point of electric vehicles is the significant decrease in greenhouse gas emissions, right? To simply put, we're transforming diesel trucks, which emits a lot of emissions every year, and just turning it to zero. And I believe that in Ontario, as of 2022, we have about more than like 100,000 heavy trucks. So all those emissions, assuming that by a snap of our fingers, we could turn all those into electric trucks, we could remove about more than like 60 megatons of carbon emission equivalents, right? Actually, there's a case study that has been done by NACFI. So NACFE stands for North American Council for Freight Efficiency back in September 2021, where they work with 13 different fleet OEMs to pretty much stage a demonstration how these commercial battery electric vehicles work, right? So they did it in different parts of the US as well as in Canada. So what they found is if we convert 50% of these trucks, or of these like heavy trucks, it could meet the current needs for heavy duty electric vehicles. So as of right now, they were saying that it is possible that converting 50% of diesel trucks into electric, that will be able to meet the current demand. So therefore, it is currently possible to cut Canada's GHG emissions by about 32.5 megatons of CO2 by simply converting them to 50%. So on the other hand, one could argue that switching to these electric trucks would simply increase the GHG emission from the electricity production side. But we know that Canada is one of the cleanest producers of electricity in the world. As a matter of fact, in 2018, 82% of Canada's electricity came from non-GHG emitting sources. So 60% of which is from hydro, 15% I believe is from nuclear. And it's very insignificant, came from natural gas or oil as well. I believe that's like one of the main selling point of converting to electric trucks. For the economic side, currently it's quite difficult to evaluate it, to give a definitive assessment because of the lack of empirical data, right? So it's a quite new technology. It hasn't been in the market for quite some time. It's quite difficult to give like a fair assessment on how economic it could be. However, many analysis or many studies in the literature agreed based on different hypothetical scenarios that they conducted that it would make a significant benefit on the adopters, mainly on the operation side, because now they simply charge. They don't have any engine to maintain. They don't have anything to clean up like in the engine. Yes, like based on the typical diesel trucks have. All the things that they need to worry about is charging, right? And from the current battery technology right now, the life cycle of batteries are quite high. I believe it's about like 10 to 15 years for battery cycle. So it could last up to the typical lifespan of a diesel truck.
What I find really interesting is when we're looking at EVs, and I understand that we always need to start small. So, of course, they start with cars first, right? But if we're actually looking at the problem and the big emitters, we're talking these heavy transport trucks. So, these types of studies are so important for us to get to that net zero, because if we don't start with, thinking about these heavy diesel trucks and thinking how are we going to make those clean, then we're going to be a long way from net zero.
Yeah, and Lysandra, you're absolutely right. And for some reason, I feel it might be easier and faster by looking at heavy transport,
Right.
to advance this in Canada. It would just have to get everyone lined up. And so the work that the University of Windsor is doing is so important to actually lay the foundation so this can happen.
Yeah, it's interesting because there's two different ways. Some people like to start big and go smaller. So that would have been starting with electrifying these diesel trucks and going to, our small passenger vehicles. But in this case, we're kind of doing the opposite. And then we get into batteries and thinking of, okay, what materials are more sustainable for these batteries and how are we going to recycle? And like Dr. Mao mentioned, the decommissioning of these batteries, we can't even start to predict the life cycle analysis of this because we haven't even gotten anywhere close to these sizing.
Has hydrogen option been considered or compared? And I think, Anna, I'm going to ask you if you could answer that question, please.
Sure, this is an interesting question. The short answer to that is no. We have not looked at hydrogen fuel cells in this project. We were concerned with electric vehicles because we were concerned about how they would impact the electric grid. But hydrogen-powered trucks is an interesting case for comparison. Perhaps this is something that we'll try to look in the near future. In general, we talk about electric trucks and these hydrogen-powered trucks. Both are powered by electricity, but they have different sources. Electric trucks are based on batteries, so they plug into the grid directly. Whereas the hydrogen powered trucks, they're powered by electrochemically converting hydrogen in electricity and eventually water through the fuel cells. So in the literature, just trying to educate myself about the technology, I can see that in general, when you try to compare the two of them, each one of them has its sort of pros and cons. And it's the same as everything else. For example, for the battery electric, in terms of the advantages, they've been adapted by many major vehicle manufacturers. So I can think of Volvo and so on, which basically translates to a more competitiveness and advance of the better technology. Another advantage basically is that electricity is much cheaper than hydrogen, especially during peak hours. Batteries are easier and safer to store. Hydrogen is highly flammable, so it's not as safe. And another advantage is that, what we've seen in recent years, that policies and incentives have been in general, pushing towards battery electric more than the hydrogen fuel cells. On the downside of electric trucks, for example, Terence can talk a little bit about that because he's been looking at the batteries themselves as part of the research here.
Yeah, for sure. So pretty much like hydrogen fuel cell, as Hannah mentioned, like they pretty much work the same way where they're powered mainly by electricity. But the difference is hydrogen fuel cell is made, the motors are being powered by, as the name suggests, like by the fuel cell themselves. So therefore, hydrogen has like a much higher energy density than the battery. So this translates into like a longer distance, right? So now the literature expects that like hydrogen fuel cell will travel far, much further than battery electric vehicles. And at the same time, it also contributes the fact that hydrogen fuel cell doesn't have any additional payload because since it's not powered by batteries, which could weigh, up to like 4 to 5,000 kilograms, right? So it would be more efficient and could travel much further because of this lack of additional payload. And at the same time, it's not using any batteries, right? So it's hydrogen fuel cell is not susceptible to extreme cold weather. So lithium batteries tend to not function as expected if the weather is quite cold, like below 20, below 30 Celsius, right?
Terence, if I may interject, that's true, but we have to also remember that um, you're talking about batteries right now and hydrogen cells right now. My general take is that eventually technology will improve over the next 10 years or so. And hopefully by then, the range for electric trucks will improve significantly. And hopefully that will overcome the problem of temperature. I mean, obviously, the payload that Terence mentioned is an important aspect. That's basically what have to keep them because obviously it will consume energy. You need basically energy to be able to carry such heavy kind of battery. My hope is that as the technology improves, and I'm not an expert in batteries, but this is based on what I've seen so far, at least in the smaller vehicle space. What we see basically what's happening is that there's always improvement. And if this is going to become a reality, my general feel is that there's going to be more efforts to improve that. So who knows? Maybe the payload in the future will not be that much of a major problem. Still, it's a disadvantage compared to the hydrogen cell trucks. And I always worry about hydrogen cells because of safety. Perhaps the cost is going to be also higher when we talk about hydrogen cells because the tanks that are going to house the hydrogen have to be of a certain material that's strong enough so that if an accident happens, the tank is not ruptured. Because the minute it ruptures and hydrogen's up in the air, you have basically a catastrophe. You have an explosion.
The mention of safety is a good one because when we think of the vehicles we have nowadays, there's hundreds of years of improvements on that safety. But now we're talking about a brand new technology that's also very hazardous but needs to be safe much quicker than what we're typically used to. So that's a really interesting point. I also wonder, is there a place for both hydrogen and EV to exist, to coexist together? Like, is there, if hydrogen's better for long and for, colder weathers, then maybe that's when hydrogen's used and EV's used for, those more stopping trips and things like that.
For sure. Yeah, I think, it's not really a matter which one is better. Because
Right.
again, like technically hydrogen fuel cell and battery electric vehicles, the main goal of these technology is to promote like sustainable environment, right? So the main point of them is to decrease greenhouse gas emission. And having a two option is actually way better than just sticking to one, because we want competitiveness, and competitiveness leads to more innovation, right? And as you have said, Sandra, like, maybe different businesses in the cold, for example, in Alberta, they would benefit more in using like hydrogen fuel cells because of their weather, right? And on the other hand, if they already have existing hydrogen network as well, so that would be more beneficial to them. Having both options as well, so both battery and hydrogen trucks coexisting, it would help to further advance this kind of technology. Right? It would help further advance, reaching that zero emission. The government as well as like, other establishments trying to achieve. So for sure, we're not trying to promote this is better
One
than like, the other
solution.
one.
Yeah.
Exactly. Like, there's no such thing as like a definitive solution. So we're kind of, I guess the cliche thing to say is like we're kind of in this together, and we're trying to arrive in that best solution as quickly as we can. And having these two options available for us, that would definitely make it like much faster to reach that solution.
Yeah, but one other thing that we have to keep in mind is that assuming that hydrogen fuel cells are made to be safe, then it boils down at the end to cost. How much it would cost to have to own and operate electric trucks versus owning fuel cell hydrogen enabled truck. One of these advantages in general of hydrogen fuel cell is basically the way the hydrogen is being produced. And this perhaps talks to the point that Terence was mentioning about greenhouse gases. Ideally, the objective in general here in Canada is to decarbonize the transportation sector. But to my understanding, one way to produce hydrogen is steam methane reforming, which is typically used to commercially produce hydrogen. And in this kind of process, coal, petroleum, and natural gas are usually the source for hydrogen production. So that's not very clean. So if we were to talk about basically clean technology, batteries would still be a better option, especially that Canada is when we think about the generation of electricity, Canada is one of the cleanest countries in terms of its electric generation.
I think Hannah and Terrence, most people don't realize that that's one of the biggest gifts we have in Canada. Is we have one of the cleanest grids in the world, and I think it's time that we in Canada and the government tout and promote that, because I think we could probably encourage more business associated with manufacturing and things to be possibly located here because of our clean grids, and certainly, as you've mentioned, the electrification of transport. It's a really a very important point. I want to come to the heart of really your study, and that is based on the work that you've done thus far. Can you share with us, like, on the electrification of these heavy transport? And I recognize it's going to change, but depending on the amount of people that participate or take this on. But what demands do you see that will occur on the electrical grid because of the electrification of this heavy transport? Can you share with us what you know so far? Because that is really important. And I know in talking and being involved in some government roundtables, I don't think they truly understand the impact and what needs to be done and how the utilities need to be involved in this in the forefront so it's properly prepared.
For sure.
So you wanna
Yep.
click on this?
So since we know that the long range electric trucks are going to be the ideal case, for these type of vehicles, because, heavy trucks tend to travel longer. In our study, we assume that all of these trucks, all of the adapted electric trucks will going to be long range, which will need like a much higher battery capacity. So again, to make things a bit simpler, we assume that it would all the trucks will have the same battery capacity. So in this case, we assume that we're gonna have about 875 kilowatt hour battery capacity. So from there to 1 megawatt hour capacity. From our initial analysis, it is common to see around 10 to 15 trucks at a truck stop per hour, right? So if we take that into consideration, we have about 800 kilowatt hour capacity for those 10 trucks, right? And we assume, because right now it would depend on what kind of charger these will have. And currently we don't have that much information with regards of what kind of charger that these establishments will likely to adapt. So we have this assumption that, let's say, these trucks will charge for half an hour. And during that half an hour, it would reach 80% SOC, so 80% state of charge. And if all of these 10 trucks charge simultaneously, we could easily see at least 14 megawatt hour electricity would be needed to charge all these 10 trucks simultaneously. As you have said earlier, Dave, to put this into perspective, there are larger establishments that have like peak demand that could hover around 10 megawatts, right? So 14 megawatts to like 10 megawatts like for those chargers, quite significant. And if we look into like a much, I guess, aggregate side of this, so if we consider roughly 20% of current diesel trucks are being converted into electric trucks in Ontario, we found that the peak hourly demand is about 117 megawatts around the chargers that are located in Peel region. And this would likely to take place between 11 a.m. to 12 noon. So which is, as we know, our peak hour at peak demand. So having around this additional demand during this peak hour, we would definitely expect that it's going to put significant pressure in the current infrastructure.
Terrence, you mentioned a point that kind of gets me thinking that I think is really interesting. When we go to get gas every morning, we wake up, we drive by a gas station and we see a new price. And right now it's not looking too good at $2 over here, but that's the price. I'm wondering, like, there's so much flexibility with electric vehicles. Are we going to have a big signage that changes based on peak time? So maybe from 10 a.m. to 2 p.m., it's a much higher price of electricity to fuel. It's so up in the air right now that I think that the next couple years, it's going to be really interesting to see how we treat electricity and if it's going to mimic the way we treated gas.
You're right. So let me just convey that I find, clients are really they understand gas pricing because they see it.
Right.
Right. But most organizations truly don't understand electrical costs. And as you said, and for our listeners in the Ontario market, that hourly cost, it changes every hour based on the demands in the grid and the type of generation that is being used to produce that generation demanded. So it will be or could be very volatile depending on how you purchase electricity. And that's in summary, I think it's going to get clients more engaged and understand the electrical market when this happens, because it will be a bigger factor that they'll have to take into account, and it will be volatile, or it could be, depending on what they do.
What's really interesting is, so across the border, I live in Windsor, Ontario, so across is Detroit, Michigan, and there's this restaurant that all around there's like moving basically stock numbers on the beers that they have. So what my friends try to do is they all purchase the same beer and it moves. The price of the beer moves. It goes up and down based on the demand. And it's really cool because I think that's an interactive way with customers to help them understand, how does the pricing work here? I think it's something that we're going to see similar with electricity. I think that maybe those signs will be changed much, much more than, let's say, those gas prices.
Yeah, for sure. I did want to do a follow-up if I could, Terrence. Did I hear that you're saying just in Peel region? And so again, for our listeners, that's just a certain area within Ontario. It's not Ontario itself. Did I hear the actual peak demand in that particular area? And I think you were saying between, 11 or 1 in the
11 and 12. Yeah.
Was that 110 or 120 megawatt? And that's just in that region. That's not of all of Ontario, right?
Yeah, correct. Yeah. So that's only in that region. So I guess like to elaborate a little bit more, because from our analysis, we identify about 91 possible locations that we could establish these charging stations. So assuming, because we know that Peel region, one of the main logistic hubs in Ontario, and we know that there's a lot of trucks that goes there. So we cannot just assign, like, let's say a few charging stations. So it's quite possible to observe that quite much of charging locations. From there, assuming that all of those 91 locations will house these charging infrastructures, we will observe an additional 117 megawatts, like in the Peel region. Correct.
Okay. And so this comes back to the heart of what you were saying, you and Hannah were saying, is the utilities will have to actually really understand this, because they'll have to have the wire capacity to ensure that they have that load that they can bring in from generation. So that's a critical point that, again, I don't think many people understand the load requirements and the infrastructure that will be required, based, which Hannah brought up at the very beginning. But so important to understand the loading capacity, so the utilities are prepared and get this infrastructure in place. Because as you said, Terrence, if they don't have the infrastructure in place, then these trucks won't come. And so, again, it's really important that this information that you're doing is shared and understood by all parties, for sure.
Yeah. Also, they like just want to clarify, since like this analysis is only based on the 20% of all trucks. So the 117 megawatt that we're estimating is only based on 20% adoption of these electric trucks. So it would increase much more as the adoption of these trucks increases as well.
Very much so.
Well, to end off our episode, we usually ask what our biggest takeaway is for our listeners. I'll kick this one off. I think the biggest takeaway with the EV, of the electrification of heavy transport, is that we're going to need to work as a group. It's going to require government, it's going to require academia, it's also going to require the industries that are using the heavy transport, all to come together and explore these options. And I think once we're able to establish that benchmark, then, then it's competition from there.
Lysandra, I think it's for sure you nailed that. I think, as I've been conveying, the work that Terrence and Hannah are doing is so important to create this awareness within government, within the utilities, within clients. So I thank you both and the University of Windsor for the work that you're doing, because I think it's so important for Ontario. And by the way, this thought process can be used in other jurisdictions throughout North America. I know you're focusing on Ontario, but there's massive learnings that can be used in other jurisdictions as well. So I look forward to continue this journey and hear more as you go through this process, because I know there's a lot more work to do as well.
Absolutely. Absolutely. The biggest takeaway in my mind is planning ahead. We need to plan ahead to identify where or when the peak demands will take place, so that we can help various stakeholders to prepare for what's coming next. As I mentioned in the context of this interview, building the proper charging infrastructure for such big trucks requires careful consideration, resources, and time. And ideally, if the plan is to have electric trucks being a reality in 2040, for example, we cannot wait till that date to start planning the infrastructure. We need to know basically where the resources need to go. We need to plan ahead. We need to understand better. We need to make informed decisions. And I think that the project that we're working on right now would give us that ability, would allow us to really understand how things are going to look like and which areas are going to require more attention.
For sure. Yeah. Like for me, I guess like the biggest takeaway is similar to what Lysandra and I mentioned, that we need to work together, because different stakeholders have different perspectives with regards to this matter. And being aware of a specific perspective for, and say, academia versus industry, as well as like government or other utilities, right? Seeing what they see will also help us to make a much more informed decision in terms of planning, in terms of how to properly prepare for such a big task that we could face like in maybe like 10 to 20 years. And it's not overnight, as Hannah and Dave mentioned. Transitioning this is not overnight, so we tend to just kind of, I guess, slack through it, right? I was like, oh, it's not going to be anytime soon. But if we understand the severity of the possibility of having this, then we could have that push that we need to act now, or to at least start planning how we could tackle this kind of a load that we could see in the electricity demand side of things. So that would avoid any possible disruptions, that would avoid any inconvenience for everybody. So, yeah.
I do have a comment, and that is I actually think this is going to come quicker than most people are forecasting. I will see if that's true. Obviously, that infrastructure is a critical point that has to be understood and calculated. But, my point at the beginning is I think this is one of the faster ways of reducing carbon emissions in Canada if you can
I agree.
get people aligned. And so if that's true and that's understood, I think that there'll be a focus from the federal government and encouraging others to move on this as well. So we'll see if that happens.
Agreed. Dave, Hannah, Terrence, thank you for your time today.
Thanks for having us.
That's all for today's episode of the 360 on Energy and Carbon podcast. Thanks for listening. Make sure to check us out on our website at 360energy.net and follow us on LinkedIn at 360 Energy Inc. Tune in to our podcast on Apple Music, Spotify, Anchor, or other listening platforms by searching the 360 on Energy and Carbon. You can watch the video recording and subscribe on YouTube at 360 Energy Inc. Email us your feedback at podcast@360energy.net or comment on our LinkedIn posts. See you next week.